calculation of consumption of thermal energy for passive house and analysis of profitability of the investment. Standards for passive houses provide stringent constraints in terms of energy consumption for heating. According to them, a building cannot be qualified as passive if energy consumption for heating does not exceed 15 kilowatts per hour/meters squared year, which is even tenfold saving compared to standard buildings. On the other hand, passive house by definition not integrated heating system with conventional fuel, only a mechanical ventilation system with sufficient capacity to meet the needs for cooling and heating. A key point to provide the necessary thermal energy limit thermal losses with greater thickness of insulation in all exterior walls, the roof, the floor, or to any physical barriers that separate the object from the external environment and neighboring unheated rooms. Additionally, the concept of solar architecture, number, orientation and thermophysical properties of doors and windows, exposure, orientation of the building etc. also contributes significantly to the intensity of the heat losses or gains. The thickness of the insulation of 30 centimeters in total area of 182,36 meters squared means additional investment from €3,774,85, considering that 1 centimeters thickness per meter squared mean cost of €0,69. Setting up windows with triple glazing and filled with argon means increasing the initial investment of around €200 per meter squared compared with double glazing windows without meeting with inert gas and PVC profile. Profile of used wood windows is aluminum as an optimal combination of thermal properties of wood and mechanical properties of aluminum. According to the area under the glazing, the total investment, the difference in investment in the application of these windows is €4,692. The total value of additional investment for passive house is €8,467. According to available data in the literature, Levy's performance of passive house is about 10% higher than its equivalent in the standard version. The choice of mechanical ventilation is reduced power of 1 kilowatts, whose annual electricity consumption is estimated at 1200 kilowatts per hour. Accordingly, the annual cost of electricity for the operation of this system, in case the total operating costs for heating will be around €80 calculated with current prices. Compared with consumption of energy for heating than the standard 14,400 kilowatts per hour facility, with annual cost of €1,045, energy saving is €965. Energy savings are huge. Almost the entire amount of energy consumed in the building is reduced to 1/10, and all provided in a sustainable manner by the building or mechanical ventilation. Assuming that venture investment in known boiler room, pipes and heaters in the case of classical heating system is equal to the investment in equipment or mechanical ventilation system with heat recover, then the analysis of economic indicators will be according to the following parameters. Saving energy equals €965. Investment value I_0 equals €1,045. Nominal discount rate K_N equals 6%. Inflation rate I equals 5%. The real discount rate is calculated by this formula. Net present value of the investment NPV is calculated as follows. Since the net present value of the project gets a positive value, it means that it is worthwhile. Profitability will check according to other criteria, or internal rate of return IA. It is the value of K obtained from the previous formula if the value of NPV put 0 lead. In this case the value of K gets 9%. So in this example the value of IA is 9%. As this is higher than the discount rate, then the project is worthwhile. If we show that the project is uneconomical, it is necessary to make intervention in architectural solution, reducing the glazed surfaces where there is considerable heat loss, etc. A change in the applied insulating materials, etc. Then the procedure of calculation of heat losses, investments, savings will be repeated. Visit us at www.pshs.gyndo.com.